Assalamualaikum and good morning everyone. So for chapter 5, I'll be teaching only for 5.1 and 5.4. Okay, so for 5.2 and 5.3, okay, you have to study by yourself. So for 5.1, this is the whole summary for 5.1. The first one, okay, I want you to put a star on it. You have to remember the properties of ideal gas, which are: first, the volume of gas is negligible. Negligible means it can be ignored. Okay. Second, intermolecular forces is negligible as well. Third, collision among particles is perfectly elastic. Fourth, average kinetic energy is proportional to absolute temperature, which has a unit of Kelvin, not degrees Celsius. Okay, for second note, we always convert the pressure to atm. So if the question gave you millimeter mercury or torr or Pascal or in Newton per meter square, 101,325. Okay, so if the pressure in the equation is in the unit of millimeter per mercury, torr or Pascal or Newton per meter square, you all have to convert it to ATM. Well, it depends on the question. Alright, so next, okay, you have to remember this. This is not given in the study guide. Okay, so for STP, standard temperature and pressure, you've already known this. The unit would be 22.4 dm cube per mole. But what about the temperature and pressure? Okay, so the temperature for STP would be 0 degrees Celsius and pressure would be 1 atm. For room temperature, the value would be 24 dm cube per mole and the temperature would be 25 degrees Celsius and the pressure remains the same, which is 1 atm. The third thing in 5.1 is I want to teach you how to remember all gases law, which consists of Boyle's, Charles, and Avogadro's. Okay, so first you only have to remember this combined equation of P1 V1 equal to P2 V2 over T1 and 1 equal to T2 and 2. Next, you have to remember the constant variables. Okay, here's how I remember it. For Boyle, there would be 2-1, Charles would be 1, and Avogadro's would be TP. Well, you know your timbalan pengarah. Okay, so for Boyle's, the constant would be the first and the last letter, which is T and N. Okay, so you cancel out the T and N from the combined equation. So cancel out this T1 and 1 and T2 and 2. So you've got Boyle's equation of P1 V1 equal to P2 V2. Okay, so next for Charles, there would be the first and the last letter as well, which are P and N. Okay, so the constant would be P and N. So cancel off P1, P2, and N1 and N2. So what are you left with? Write it off as the Charles law. V1 over T1 equal to V2 over T2. Lastly, the Avogadro law. Okay, Avogadro's, you just have to take T and P. So that would be, the constant would be temperature and pressure. So cancel off T1, T2, and P1 and P2 from your combined equation. So you've got V1 over N1 equal to V2 over N2 as your Avogadro's law equation. Okay, so that's how I remembered my gases law. Okay, so just be creative with yourself. You don't have to remember everything and cram everything into your brain. Okay? So before that, I want to tell you that P stands for pressure, V for volume, T for temperature in Kelvin. So N would be your mole. Just remember that the units for pressure and volume in moles, it depends on calculation. It depends on the question given. Okay, but for Charles' law, you have to remember that the pressure must be in Kelvin. So how do you calculate from degree Celsius to Kelvin? Okay, so Kelvin would be your temperature in degree Celsius plus 273 Kelvin. So for example, I've got 25 degrees Celsius plus 273 Kelvin. So my temperature would be 298 Kelvin. Okay, so use the unit of temperature in Kelvin in your calculation for Charles' law. Okay, for Avogadro's, again, all the units depend on the question except for temperature. For Charles, it must be in Kelvin. Next, the whole summary for gases law. So the first one is Boyle's law. So for Boyle's, so refer back to your constant variables. So the constant would be T, temperature and mole. So at constant temperature and mole, volume of gas. Okay, now you need to rearrange this equation. So P1 equals to P2V2 over V1. Alright, so the relationship between P1 and V1 would be inversely proportional. So the volume of gas is inversely proportional to its pressure. Right, so the equation would be P1 V1 equal to P2 V2. Has three graphs which are, so the first one is about pressure versus volume. Okay, so the relationship is inversely proportional. So draw your graph like this. Okay, what about for P versus 1 over V? Okay, so the graph would be directly proportional. And the last one, if you are given PV as y-axis and pressure as your x-axis, the graph would be constant. Okay, next is Charles' law. At constant point, constant P and N, volume of gas again. Okay, so what are the relationship between V1 and T1? Okay, I want you to rearrange this Charles' law equation. Okay, so make sure that V1 is equal to V2 over T2 in bracket T1. So the relationship between V1 and T1, okay, it's just the same. It would be directly proportional. Okay, you have to compare between V1 and T1 to its absolute temperature. Okay, again, absolute temperature. Okay, it must be in Kelvin, so you have to add 273 Kelvin to your degree Celsius temperature. Okay, the equation for Charles would be V1 over T1 equal to V2 over T2. Okay, again we say that the graph for V and T in Kelvin, okay, emphasize on the unit class. Okay, for the graph of volume over temperature in Kelvin, that would be directly proportional. But for volume against temperature in degrees Celsius, the graph, again, it would be proportional, but you need to extrapolate it at the back. Okay, so this line, okay, would touch the point of negative 273, which is your absolute temperature. Okay, lastly, the Avogadro's law. Okay, for Avogadro's, a constant timbalan pengarah Tp, T and P volume of gas is again directly, okay, so you need to arrange N1. Okay, so your Avogadro's law would be V1 equal to V2 over N2 times with N1. So your equation, so your relationship would be V1 is equal to N1. So the relationship would be directly proportional to its number of moles. So just copy down your Avogadro's law. V1 over N1 equal to V2 over N2. Okay, so Avogadro only has one graph, which is V over N, which has a directly proportional relationship. Okay, fourth, the ideal gas equation. Okay, so that would be PV equal to nRT. Okay, remember class, for ideal gas, use this equation of PV equal to nRT, where your R, which is your gas constant, so R is gas constant, would has a value of this number and this whole unit. Okay, so you must know that you must follow the units of constant for calculation. Okay, so your pressure must be in atm. Okay, pressure must be in atm, volume must be in liter. Mole, okay, it doesn't have any any unit than mole. And R is this number. T, temperature must be in Kelvin. So we always use the ideal gas equation to find the molecular mass and density. So first, to find the molecular mass or MR, okay, you need to substitute the mole in here to mass over molar mass. So PV equal to mass over molar mass times RT. Okay, so rearrange your equation. So PV equal to mass RT over MR. So your molecular mass would has an equation of mass times RT over PV. Next, to find density, okay, you have to, the equation will originate from here. Okay, you know that density is equal to mass over volume. Okay, so now you've got your mass and volume in this equation. Now convert it to your density. So you've got molar mass equal to density RT over PV. Density RT over P only, because we already combined this volume as your density. Okay, next I want you to try out these questions. Alright, so that's all for the summary for 5.1. Make sure to remember all the formulas, okay?